So what were we doing? So this, what I wanted to talk on was on on-chain AI agent constraints. So first go through like why does that possibly even matter in the first place, and how exactly does it work? There you go. Cool. All right. So first, it's important to define really what is really an AI agent doing. And so an AI agent is a piece of code that can plan, decide, and act independently. And so what that really allows them to do as an AI agent is, unlike anything in the past, like bots or even workflows, is they're able to reason, right? They're able to reason and reflect and do something. They're actually able to think about it and then say, wait, I'm going to take an action based off of prior history, information that I need to verify all of those things. And then the other really big part is that they can plan and take complex actions, not just a single step, but think about what are the effects of the actions that they take and then respond accordingly. So in this case of what we've talked about at that intersection of crypto and AI is really that we're envisioning a world of an agentic economy, right? That is enabled both by AI agents, but also kind of fillers, solvers, all these different things that are responsible for executing transactions and really moving what we call the entire financial system forward. And there's a lot of different things that AI agents can be used for, and these are just some of them, right? So it could be used for portfolio management. Quite relevant in a world when there's lots of assets, both on-chain and off-chain. Also for liquidity pool management. So, when we think about our Uniswap liquidity pools, our borrowing and lending pools, our solver inventory. The other one is, of course, yield, right? So how do we generate yield as individuals? How do we want to do that? The other one that I don't think we talk about as much is actually like full-out execution of payments. And that hasn't happened yet, but it's also very relevant in the world of fintech, is the actual movement of money itself. So I need a payment executed. Where all does it have to get routed to? How much do I want to spend? All of those types of categories. And then, of course, I think you guys have probably seen a lot on meme coins and NPCs for gaming as well. So what could possibly go wrong with AI agents? A lot. So you could have a jailbreak that you take advantage of it and then you're able to exploit a ton of funds out of it. You could have it where the AI agent's like, great, I'm just going to spend all the money at once. And you're like, that was not at all what I wanted. That's a really bad outcome. Adam at Polygon was like, an AI agent is very feasibly able to send money to a sanctioned entity, which is probably not what you want it to do when it's your own money that you're holding. Another one, of course, is malicious contracts. So interacting with a contract that hasn't been audited or even is a malicious contract, and now you've suddenly experienced an instance of loss of your funds. Whitelist, and there's a lot of other things that you need, otherwise things can go really poorly. So we can look in traditional AI in terms of how you kind of deal with that system. And so this is like a high level kind of overview of it, but really the concept is guardrails. So guardrails are you're trying to set some type of constraint on what your AI agent can do. And when we do that, it's also meant to be deterministic. And so the general system here is we have kind of a few different pieces. So you have your checker, and what the checker does is kind of what it says, right? Like how it's described is really it's checking to see if there seems to be anything odd, something that shouldn't really be there. The corrector is the one that's saying, all right, something has been flagged by the checker, we need to fix this. Then you have rails. So rails are the things that actually essentially manage the interaction between checkers and correctors. And then the last piece here is a guard. The guard is responsible for managing the overall system across all of your different rails. And in the end, they're kind of getting you to that final output based off of really those different the interaction between checkers and correctors. And so there's different types of guardrails, or actually let me say there's guardrails that function for different purposes. So here there's kind of 5 key ones: appropriateness, hallucination, regulatory compliance, alignment, and validation. For appropriateness, it's saying that, hey, does this actually meet like the general scope of what we want? And so it's like making sure that, for example, is the content appropriate? Is it saying really bad stuff that I don't want it to say? Think of like a Twitter bot, right? Of like, is it providing harmful content? Hallucination, I think that's pretty self-explanatory, but an AI agent hallucinating. Regulatory compliance, I think, is also relatively straightforward. Alignment is one of saying, hey, is the agent actually aligning to what like my core purpose or what I really wanted to do? So making sure it's constrained within that and not doing something else. And then the last one is validation of saying, is it doing actually what I want it to do from an end outcome standpoint? So this is all used in traditional AI. And there's a lot of innovation that's happening in that. So there's Hugging Face, NVIDIA, OpenAI, LangChain. All these guys are doing different models and for basically for guardrails. So then I want to make that tangible, because most of how we interact right now with AI today is probably on crypto, like a Twitter AI bot, right? Which is tweeting stuff. So if we go through when we talked about guardrails for, let's say, appropriateness, it's making sure that the content is not toxic or harmful, right? Or, for example, it's that it's not talking about a contract and saying, oh, hey, go and buy this token, but it's actually from a malicious contract. You don't want a bot, or you don't want an AI agent to be telling you that and saying, oh, go and interact with this contract. Something where you want the information to be accurate, not misleading. Regulatory compliance actually does matter for some of this, right? Like if you have an AI agent who's like, go clearly buy something that you're not supposed to buy if you're in the United States or in Europe, and you're like buying something that's not, for example, MiCA compliant. And then yeah, alignment is it's actually matching the user expectation. And then for validation, you might want it to have certain things as a baseline. For example, not financial advice. So this is all how it might work in a basically like a Twitter agent. Okay. When we then turn into like more, I think, complex and sophisticated AI agents, that's when we start actually looking at them from a smart contract standpoint, of them executing transactions on chain. And when that happens, it starts getting a lot more, there's a lot more risks, right? Because now they're responsible for moving funds on behalf of individuals or organizations and interacting with different contracts. And so that's where it becomes really important to start verifying those with guardrails. So things such as like checking for smart contract risk scores. So an AI agent, before they interact with the contract saying, oh, I'm going to use your funds, you do want them to, for example, say like, is this a malicious contract? Is this something that we should be worried about? Checking for compliance. Are we about to interact with North Korea Lazarus after Bybit, right? Probably something you don't want. You might want them to only interact with certain people, rate limits, certain types of transactions you want it to do. All these things are basically what you would envision or need for agent guardrails when they're actually dealing with a smart contract and they're like, hey, we have access to funds and we're going to execute on this. And so there's actually a way that we can think about it from a general design standpoint. So this is actually how we've been thinking about it from Predicate. So I know there's a lot going on here, so I'll just kind of walk through it. But essentially a user is going to have to create an AI agent policy, and that is done from a client interface, for example. So this could be through a smart contract wallet, such as a Safe or a Coinbase wallet, anything like that. So then what happens here is that you're setting a policy, and then the entire system on our back end is essentially managing an entire operator network who is responsible for issuing signatures. So our entire operator system is the thing that functions to set your guardrails. So we're saying that in this case, a transaction only goes through if it's checked by our operator network. The operators here can reference any type of historical on-chain or off-chain information. So to make this more tangible, you set an AI agent guardrail that you don't want them to interact with a contract that has not been audited, for example. In that case, what happens here is you set that constraint for your wallet. Then, if the AI agent is about to interact with a smart contract, what would happen is our operator network would be able to say, great, it's interacting with this contract. Has that contract been audited before? And there's different sources of information for that. So there's all different places that kind of curate and create lists of whether smart contracts have been audited, what the level of audit is, all of those things. If it meets a certain requirement, the operators say, this is good, and the AI agent can execute the transaction. So then turning it a little bit more specifically to how it would work from a wallet standpoint. And I think, David, you're probably going to touch on this as well right after. But yeah, so you have the AI agent. The AI agent is part of a multi-sig wallet, right? It's essentially controlled by a multi-sig wallet or a smart contract wallet with conditional signing. So when the AI agent has control of the wallet, you basically are having a requirement of a signature from the predicate network for that transaction to get executed by the AI agent. If the AI agent does not have a signature from the predicate network, as per the guardrail, the transaction cannot get executed. And so there's an entire world around how you make this verifiable. This is how we use EigenLayer as well. But the main premise here is that a transaction does not get executed by an AI agent because it requires a signature from the predicate network. So that's essentially how the whole system works, and you're able to kind of build a full end-to-end flow. And so with that, I think kind of start closing it up. But really at the end of the day, what we're doing is our view is that policies are a critical infrastructure when we think of an agentic economy. And that's simply because we have to be able to control what happens for our transactions. You can't leave it fully out in the open. We do have preferences, we have requirements as users, as organizations, across all different facets, especially when we're dealing with financial transactions. And so with that, thanks everyone.